Hi everyone. Today in this video we are diving into one of the most powerful features in Java introduced in Java 8, the Stream API. We shall see what the Stream API is and why it is useful. And we shall also look at some hands-on examples to understand it comprehensively. So let's get started. When we talk about the term stream, what actually comes to your mind when you hear the word stream? Maybe a flowing river or a pipeline carrying water. This is actually a great way to visualize what a stream is. Imagine a river. Water flows in a single direction. And along the way, you can do things like filter out debris, clean the water, and direct it to different places, right? However, you don't stop the river or change its source. You just process the water as it flows. Similarly, in Java, a stream represents a flow of data. You process the data step by step, filtering, transforming, and aggregating it without modifying the original source. A stream is like a pipeline that processes a sequence of elements. These elements can come from a variety of sources. I mean, different from different collections, you may say, like such as list, arrays, or even a file. Each operation in the stream processes the data and pass the result to the next step, just like water flows through a pipeline. Intermediate operations are the operations transform a stream into another stream. These operations are lazy, meaning they are not executed immediately, but only when a terminal operation is called on the stream. They are used to process or filter the elements of the stream in a pipeline. For example, some commonly used intermediate operations are filter, map, sorted, distinct, and here collect is a terminal operation. Before jumping in code to let's see few characteristics of streams. Sequence of elements. Stream process data sequentially or in parallel. No storage. Streams don't store data. They process it and pass it along to the next step. Lazy evaluation. Streams only process data when you trigger a terminal operation like for each or collect. Immutable. Streams don't modify the original data source. They create a new stream with the processed data. So enough of theory. So let's jump in code to understand with the help of some examples. Let's understand with the help of an example. We have a list here. When I do something like this, name dot stream, it actually makes this list as a stream. So I take a stream variable of type string. Now I apply an intermediate operation on the stream like stream dot filter. Say name. I say filter all the names which contains a character. If you see this filter method again returns another stream, right? So I take another stream. Okay, I have now filtered stream. Now what I want to do, I want to consume this stream. So I do something like this for each and I run it. You see, we have printed names from this stream. Remember, once stream has been consumed, it is not available for the later operations. Once you have processed a stream, it is considered consumed and cannot be reused. This is why you need to be careful when chaining operation on a stream. So let's see what happens when you try to reuse a stream. I copy paste the same line here and when run it, let's see what happens. So let's see what happens when we try to reuse this stream. I run this program. See, so it has printed names for the first stream, but when we try to reuse the same stream, so it says stream has already been operated or closed, right? So we cannot reuse a stream. Okay, instead of writing this lengthy code, we can also write all of this code in one line. So let's make it shorter. I do like names. I use lambda function. Okay, I replace that code with only one liner code. So let me run it and we get the same output. Okay, just to explain, lambda functions are implementations of functional interface in Java, right? A functional interface is an interface that contain exactly one abstract method, right? So we will discuss functional interface some other lecture. So for now, we keep our focus on Stream API. Now this Stream API has made our task quite simpler because without Stream API, we would have to do the same logic with some traditional approach like this. Now you can see we can replace all of this traditional approach with this one-liner Stream API code. Okay, let's see another example. Let's suppose now we want to convert some names into uppercase. which starts from A. For example, Alice and Alex. So we want both of these names to be uppercase. So let's write code for this. Map is used to transform data. Map says, hey, I will give you a value. You tell me what to do with this value, right? We gave him a value. Value is a name. Using filter method, we got a filtered stream. We passed on that stream to map method. Map method transformed all the letters to uppercase. And finally we use our terminal operation dot for each. Let's run this code. You see, both the names have been transformed to uppercase. You may see that we have used double colon here. Just to explain, these are method reference operator. Method reference operator allow you to call method of a class by using the class name instead of creating its object. Without method reference operator, we may have to write our code something like this. Run it. You see, output is same. So it's a concise and short way to call the method. Let's see another example. We have a list of numbers and we want to take sum of even number from this list. So let's write code for this. After the filtering, filter will give us another stream, and that stream will be processed further using the reduce method. So it will call the sum method. Binds all elements in stream by summing them, starting from 0 and x. Okay, so we got the sum for all the even numbers. So let's see another example. Let's see this example. We have an employee class here which has two property, age and name. Here we are creating a list of employees using array list. Each employee has name and age. Now for example, we need to get only those employees whose age is greater than 20. So let's write code for this. Okay, so in previous example, we have used for each as terminal operation. So in this example, we will use collect as a terminal operation. Okay, we got the filtered employee. So now let's print their name and age. So we are printing their name and age. So let's run this code. So we got the answer, right? So I hope so far we have good understanding of stream. Apart from stream, we have parallel stream as well. Parallel stream are part of Java Stream API that allow data processing to be done in parallel, utilizing multiple threads. This can significantly improve performance when dealing with large dataset by dividing the workload into chunks and processing them concurrently. How we can use it? It's very simple. The parallel stream method or calling parallel method on a stream switches the stream to a parallel mode, right? Let's convert this example into a parallel stream. So let's add a few more employees in it. Now instead of stream, I call parallel stream method here. Now let's execute it and we got the output. One key thing to note is parallel stream don't guarantee the order of processing our results. One question is when to use stream and when to use parallel stream. If you have large dataset like thousands of employees, so it's better to use parallel stream. I hope you found this explanation helpful. If you did, give the video a thumbs up and don't forget to subscribe for more developer friendly content. Thanks for watching.